On our previous video, we talked about the Bronsted-Lowry acid base pair with the conjugate base and looking at also Arrhenius acid and bases. Now we're going to see how we will apply those concepts in this particular question, which expresses a specific compound right here. And what we're going to do is to add acid to this particular solution that contains that particular compound. So if in here we have our compound, which is sodium with two hydrogens bonding with this particular polyatomic ion right there, we actually notice that first something will actually happen before we actually add our acid. Now, for the purpose of this video, we will focus on the acid to be the one that actually contains a hydrogen ion right there, or we can say in terms of looking at the Bronsted-Lowry, which is a proton donor. So once you actually understand that particular concept, then let's look at a little bit of the chemical structure of this particular compound. We know that in here we have phosphorus, which is actually attached to 4 oxygens, but there's a little twist in here. One of the oxygen is actually double bonded to the phosphorus because phosphorus has a multiple bonding interaction. So now that's out of the way, we have the other oxygen right here, and we have this other oxygen right there. This oxygen has a negative charge with a couple of lone pairs right there, and then this has 2 lone pairs. This one here, since it's going to be bonding with a hydrogen, will have 2 lone pairs, and this one here will bonded to a hydrogen which has the oxygen with 2 lone pairs, and here we'll have our sodium with a positive charge on it. So since we've looked at this particular chemical structure, we can actually dive into the first reaction, where in here we are adding the acid. So first, what do you think is going to happen? We're going to perform a dissociation reaction so that we can break free this compound that will be involved in the protonation of it. There will be a hard dissociation completely, where we have our sodium ion and we'll have 2 hydrogens attached to our polyatomic ion with a charge of -1. So once that is actually done, the next step is that we actually use this particular compound right here, because the sodium doesn't contribute to the acidity. Therefore, the next step is to actually perform a neutralization reaction. This is going to be subjected to the addition of the acid, which actually contributes a proton, and what happens at equilibrium is the formation of our product, phosphoric acid. So what here you notice is that the overall charge here on the left side is -1 plus 1 gives you 0, and here we have the overall charge to be 0. So what you notice here is that we're able to produce our product here by a neutralization reaction, where in here this particular compound is actually acting as a base, and this particular species, which is a proton, is the acid, and then the base here actually produces a conjugate acid. And well, if you want to add a side product, the side product is the formation of water, where water is actually considered to be the conjugate base of this particular acid right there. And for this, we have the conjugate acid of the base, which is what we have right there. Now you might be asking, where did this water come from? Sometimes we can actually put our hydrogen ion to represent an acid, or you can actually use a hydronium ion to represent the addition of an acid. So now that's out of the way, I'll let you all to solve the second question, which is when the reaction occurs by adding this particular compound here in a basic solution. Once you solve that, I'll give you 3 seconds, pause this video, and once that's out of the way, let's just jump right into it. So first one is that we'll have our dissociation happening again. We have our sodium with 2 hydrogens attached to the phosphate right there, and we're going to have a direct dissociation. And what we have here is that we perform the next reaction, which is a neutralization reaction, but this time this particular compound is going to be subjected to the base, which we're going to represent as OH minus. So at equilibrium, what's going to happen is this R hydroxide will actually pick up one of the hydrogens right here, and what is going to happen as a result is that we'll have a hydrogen left with this particular phosphate, but now the charge is going to decrease and it's going to have a -2 right there, and on this other side we're going to have water actually formed. So in here, this part here is actually considered now to be our acid, and this is going to be considered to be our base. And once that is done, our product here is coming from the acid, which is going to be the conjugate base, and water here will be the conjugate acid of the base right there, and while this one is right over there. So that's about it for this particular video. Hope you're able to understand this particular reaction on what happens when you actually add an acid or you add a base to a specific compound solution right there, which involves first dissociation reaction to be able to gain access to the critical polyprotion right there, and then you perform your neutralization reaction by either adding an acid or a base or the same. Stay smart and believe in yourselves.